Hello and welcome to this construction domain session as part of the buildingSMART International Standards Summit, Lillestrøm 2023. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Use Case Presentation. The speakers for this session are shown on the screen. The session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is an hybrid event. For online attendees, your microphone will remain muted for the duration of this session. And if you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring your attention to buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Veljko.
Thank you, Laura. Welcome, everyone. So I'm Veljko. I'm president of Bexel and also steering committee member of construction domain within buildingSMART International. And also in Europe, we have a European Association of Consulting Engineers, and I'm a vice chairman of BIM and digitalization. So about us, just 72 countries, around 350 billion projects all over the world, very different types. Here are some currently localized in 14 languages, and here are some of our clients. So what we believe is that BIM could be more or less equally successfully used in infrastructure projects or high-rise buildings, oil and gas, and so on. And on the left-hand side, you can see some statistics. So that somehow it works, so more or less equally successfully used on totally different types of the projects, and primarily our clients are the guys who can lose or gain the most of the project. So the owners, investors, developers, and contractors. Of course, we have also designers and asset management companies. So this is about our ecosystem, but I will skip with this part because I used to say that the ecosystem should be complex and user interface should be easy, not the opposite. But nevertheless, we are IFC certified, and all our workflows are fully open, like IFC, BCF, and open APIs, and so on. So just want to, when we are talking about several things, so one is common data versus common document environment. So I'm going to talk today also about some big question, why we are saying common data environment and think about just and focus on common document environment. So I hope really we will switch from this concept to really truly integrated data environment. And this is an example, and what is really the vision of execution in a construction phase. So where we are today, we have, for example, CD or BIM authoring tools on the left-hand side, and then we attach all the other systems to the elements, to selection sets, and that's state-of-the-art technology where we are. And the key challenge with this is, first of all, we don't have a single source of truth. So we connect a financial accounting system to which was 3 months ago updated, then with a Gantt chart, which was 6 months ago, then with the, I don't know, some energy analysis, which was done a month ago, and these data on monthly payment certificate, which was recently published, and then this data is not consistent because they're coming from different sources. And the second, this is the first challenge, and so this is a time component, so we have a different routes. And the second challenge is that we need to manually update all these things, and it won't work. Because if we don't have that, the statement I use frequently, without automation, it won't work. Because simply, in terms of project management, construction projects are by far most complex human ventures. So this is true, and you never see such a level of complexity in any other industry in terms of project management. And handling all this is extremely difficult and doesn't work if we don't have automation. So the idea is to have the opposite approach, where most of the data is generated automatically or almost automatically, and then connect with the rest. But the data, majority of the data, like cost estimation, construction schedule, carbon footprint, we are successful in certain areas like clash detection, or now I'll show you today IDS. But we have a full automation, but the same thing we should have for the rest, monthly payment certificates and so on, because otherwise, if you need to do it manually, it won't work. And the idea is to have this holistic contract management, total project control, and so on. So this is one of the ways what we can analyze. I will, at the end of this presentation, just show you some dashboards. So the idea is that instead of static documents, when you approve something, you approve dynamic interactive documents. So it's a on one side a bit more challenging, on the other side gives you much more insights and flexibility when you analyze the deliverables. So, but you will see some examples and results. So I already mentioned that we need also to develop fit-for-purpose data. So I'm not a big fan of all the unnecessary requirements. So I always insist, keep it simple, but then deliver it properly and well. So this is much, much better than to ask everything and then to have a 50% of everything, but because then there is no single result of this. So take care about this. So what we always do, whenever you develop requirements, if you are the owner, we sit down with you and say, can you show us in any report, chart, or dashboard where you're using this data? And if the answer is no, then we say, okay, why you ask this and not use this? So what is also important, what we are trying to do is with this automation is to switch what assembly lines and Henry Ford and Toyota did a long time ago, to do that in construction industry. I'll show you some examples. It's so obvious and it works. And this is a research done by McKinsey. They said that could lead to 5 to 10 times productivity boost. I don't have a slide here, but my answer to all of you is, what is the current efficiency on the site of the workers? Theoretical maximum is around 70%. So it's never 100. You need to some time to prepare, to come to the site and so on. But what is current status?
30%.
It's 15. And when I was at Stanford a couple of months ago, and I saw in this slide in my presentation, Martin Fisher, CEO of Stanford, Saifi told me that by his research, it's 7. Okay, so this is a huge gap, and this is our opportunity. So one of the opportunities we have. So I will just move to these are some of automation workflows we have in Bexel, but I will just want to show you some of them. So let me just ask you, shall I now just click here? I know it's video now. So this is one IDS. So we will show this, my colleague, tomorrow, and this IDS challenge. So just, are you familiar? If you're familiar with IDS, so this is the system how Bexel automatically load the requirements and publish interactive results. I would like to start with this because data checks are extremely important. So you draw now IDS, then the system automatically performs all property checks, so which properties are mandatory, and so on. And then what we have here, ability to automatically create selection sets. So now the system created around 170 selection sets. So which property is missing? So in wall, we don't have the type of the door, or we don't have if the wall is bearing or not, or any other or relationship checks. And then you just drag and drop this to the BCF server, and you can upload and share with the designers who are using Revit, Archicad, or any authoring tool, so they can see what data at the moment is missing. But the idea is to do it literally in 1 minute. If I need 5 hours to do that, I will do this once, and then I will be so busy and could not cope. That's why automation is important. What we also did is we combined this with our cloud Bexel CDE, so where you can export these data now on the cloud and create interactive dashboards. So instead of just sending to them PDF, this data is missing, this is an implementation, and everything is available on our website. You can even go and see these templates and play around with the data. So the idea is you can visually see what is missing. These are color schemas. So for example, which properties, which elements have 3 properties missing, 5 properties, or are perfect. And then you can isolate this, and whenever you click on some elements, the system will zoom and show you which properties are missing. So the idea is that you always have a control, and these are interactive dashboards. So instead of a single document, maybe in the future, we will approve or receive this type as a report. So why this is important? Because it's interactive. So if I want to zoom in or rotate or see better what's missing, I can do that more effectively. This is another type of dashboard for materials, but this is fully flexible. So you can, I will later explain what is the difference of this type of the dashboards and fully interactive ecosystem. But still, you have a lot of this type of dashboards available, and this is another implementation. So you don't necessarily need to have ideas, which is brilliant, but this is a template, for example, we develop for our German clients. And because this is now translated into English, but originates from Austria and Germany, that they would want it sometimes to simplify the IDS checks. But again, you see the dashboards and analytics, and you can filter and see the results in interactive way. So the idea is that there are different levels of checks. So you have if the value is property is attached, if the value is a proper type, so if it's text instead of numeric, then if you define the ranges of the values allowed, the system can tell you, okay, the value is there, but it's not in the list of accepted values. So why this is important? Because if you want to do any analysis, you should start with this. The next thing is the concept of today we are too much dependent on designers, which I don't believe it's always fair. So just give you an example. We worked on some relatively large projects like this football stadium, and designers, because he's focused on his work, did the duct work and pipe work for the entire stadium with the several surrounding objects in a single IFC file. So if I'm about to do a clash detection or to show this to the client, I need to load all the data because it's organized in that IFC file. And sometimes I don't have a good laptop or internet connection. It won't work or work very slow. And I just want to do a clashes on a small zone of the west part of the stadium. So what we did is we do a pre-processing automatically. Of course, you can customize the data and slice the IFC files according to your needs. could be fully flexible system. But usually what we suggest is to divide the model in the zones. So could be building stories or buildings. Then on the other side, if you have a large project like in 4 or 8 subzones, and then this is the first part. So you can have a multi-level. So you can have building and then building story, or above ground. So you can have a multi-level zones. And then is this functional part. So functional part is to divide up the model based, for example, it's architectural, but facade will be separated, structural. So I want to see only the things I'm interested at the moment. And we added, I will show you later, but of course it's fully optional, a third level, which is level of complexity of geometry, which is an interesting, I'll show you some interesting findings later. So in this case, and then this is presented number of times, so I don't want to talk about this. This is the way how you automatically, in an intelligent way, generate the schedule in Bexel project management engine. But again, the workflow is not to import it from Primavera. Of course, my colleague will show some examples today, and then in the afternoon you will have one American client, Clayco, using this, but you will see pros and cons of Primavera and also Bexel workflow, but both options are okay, so you can import. So just to see this part, just simplify how it works. So this is a football stadium for the previous World Cup. So it has around 600,000 elements, quite complex geometry. So this is how you analyze zones. And then in Bexel, you can define what we call methodology or strategy, method statement, how you are going to build your project. And then the system automatically creates around 50,000 tasks. And the same goes with the cost estimate. But there are a number of presentations available. I'm not going to talk about this today too much, but you can see just it's an ideal scenario. You just load the template and the system automatically creates simulate. But then later, then you can do a fine-tuning similar like in Project or Primavera. So you can slightly enhance tasks. But the benefit is that all resources, so in this case, you have around 17,000 tasks and 32,000 relationships. So again, time is the essential. So if I can do that in a relatively short period of time, I will do that. Otherwise, simply I will focus on a lot of other things I have to do. So, but you can see literally every hour what's happening. Can this be done manually? Sure. There are semi-automatic ways, but this is a more consistent and controllable way because you have then line of balance and other stuff, and these are some of the dashboards with earned value and so on. But I will move forward and there are available workflows which in detail describes this strategy. But I will now just mention about the progress monitoring and then some also interesting findings about the model itself. So in this case, what is when you have generated model, obvious workflow is to manually enter 30% is finished and so on. But in this case, you can communicate with the expert system, Bexel Manager, and cloud system. So you can send very easy look-ahead plans for each subcontractor, each field engineer to the cloud. And then he can easily highlight what is planned to be done that week, that month, and so on. Later, I show you the process, how the works are accepted. And then you, for example, just decide that certain elements are not finished accordingly, and you create a BCF or selection set, what actually was done, and send back first to supervisor in some countries, or in the countries where supervisor does not exist, directly to the project manager. So they now accept this, and the benefit of this workflow is that they will immediately see the actual quantities. And this is a use case where you can also, if you want, of course, like in a document management system, connect to that monthly payment certificate any document, like photos or anything which is necessary, or report, or so The ability is to always connect the documents, not just as a standard document system, but to the elements or group of the elements as well, because then it's useful whenever you highlight certain elements, you only see reports connected with them. And in this case, you can see example of the dashboard. So where you are tracking the progress in this way, you can immediately see planned versus actual, but not just in numbers, but you can also visualize. Let's say, so this is left-hand side, what's planned, right-hand side, oh, sorry, opposite. What's planned and what's achieved on the right-hand side. So you can see interactive each month. So again, this could be a report. So not just the formal, but fully interactive. So I can always go back and see, okay, is it correct or not? And then with color schemas, you can always choose the different types of the dashboard, such as this case. Okay, this is not a good example, but you can see red, everything which was planned but was not achieved. So just for a certain type of the work, so it's just for facade works or per subcontractor and so on. So what we realized is that when you show these dashboards to subcontractors, they will be more productive because they will understand that the progress is realistic. And then what we also found that sometimes subcontractor top managers like to have this because in a lot of cases, they don't know what truth is. Their guys on the side said, oh, the contractor hates us or the investor hates us. So, and they see that it's not okay. So they don't know what truth is. So a lot of times, even subcontractors say that they are thankful because they knew in the beginning if they're going to achieve something or not. And this is the way how, let's say, one ecosystem could look like with the documents, dashboards, reports, and color schemas, and so on. But I would like to now move forward to the concept of how you develop a fit-for-purpose organization of your model. So you have here 2 buildings, around 200,000 elements, but you don't want to load all of them at the same time. So in this case, you can in Excel, smart selection sets are generated. So I will first slice the model per building, then by subzone, then by functional level like architecture, structural, MEP, or I can have mechanical separated of plumbing and so on. And then you just slice this and the IFC files generated on the cloud will be organized in the way you desire. And so just the workflow is you just, instead of publishing per source, you create any selection set structure you would like to have on the cloud. And you just choose which color schemas and everything you would like to have. And this is the end result. And so you have now this color scheme, but the idea is you can filter the properties as see. And now, for example, you see entire animation. But what you can do is just isolate structural works, like on the right-hand side, or below are just the walls, or on the left-hand side below is just one zone, but with all MEP and everything. So you decide what do you want. But what's a key difference, you have also selection sets in CD, but the difference, main difference is that in this case, Excel dynamically CD loads only important data, what you need at that moment. So if I have in my 4D, 5D simulation, football stadium, and I'm about to see a 5D, 4D, 5D simulation, and I just isolate one floor of the stadium, the system will dynamically load only relevant data to this. So when I add another floor, he will say, okay, now I need to add additional elements. You have even a opportunity, if I have 2 separated projects, but they are geographically close, that I just load the part where the 2 small zones of both projects are loaded at the same time and analyze only this connection zone and see a simulation of 4D, 5D of the project I never managed separately. So this is, the idea is that whenever, or the document management have the same concept. So whenever I load just those elements, the system can load only documents relevant for this. So not necessarily to manage all the data. The next thing I would like to also mention is, I said that there is a third level, how we suggest dividing up elements. This is based on the functional usability and also complexity in terms of geometry. So in this case, this is a simple dashboard, color schema, where the model is colored based on the number of triangles or faces you have in a single element. So I'll just give you an example of one similar project like this size. I don't want to mention country where it was, but we had a situation that 26 chairs in that project contained more triangles than the remaining 100,000 elements. And you have a loading issues, you are on site, maybe internet is not perfect, because an architect decided to use a perfect rendering chair with 300,000 triangles. Average wall have 24. So it's a 10,000 or 12,000 walls you can have in the model or slabs for one chair. So that's the thing, what we use in requirements when we are consultants or define requirements for the owners, we said, okay, define the maximum allowed number of triangles for a certain element. So if it's crane, could be even 10,000, because crane is almost a building. So it's fine. So Bexel, in intelligent way algorithms, some AI algorithms, define what is relevant, and you have 4 levels or 5 levels of detail. So I'm about just to see a 4D simulation. I don't really know, want to load every, for example, fitting. Fittings are sometimes extremely complex and could have 5,000 triangles, and they're extremely small. So maybe, and they're not even so relevant for clash detection. So just an idea, what we usually suggest when you define a clash matrix in Bexel to do a clash management and clash detection, you can speed up the process by just excluding the elements which are tiny and on the other side have a complex geometry. And the same goes with all other analysis. So you have a flexibility in Bexel to load level 1. I will show you some examples. They are available publicly. So you can see that model loaded the level 1. And you will see just a small fraction of the model, but when you go and see a 4D, 5D simulation, it will look very, very presentable and can be run on a tablet. I can show you how it works on my mobile phone. So these are examples. So you can see now with the color schema, green ones are the optimal or the elements with low triangles, but then you can see some beds and chairs here which are orange or red because they contain a lot of elements. And they slow the system. So we are here what we call building information modeling, not visualization. So we should be very careful when we are developing models and what is the main goal. This is an example of the zone. So for example, in this case, you just decide to see that 2 parts of the building and load the data and simulation and everything just for that part. So you define what and how you would like to analyze the model at that moment. It can be one story or whatever you want to see. So this is now an example where you can filter what you want to see, and then you just load that data, and in this case, just see a simulation for that part. So of course, you can see entire simulation if you have a good laptop like mine, but sometimes I'm just on the side, have tablet, and I really don't want to load all the data. The second benefit of this fit for purpose models is a progress tracking. So we have a projects like, let's say, 1-2 billion euros railway projects, and I'm about as a field engineer to track the progress. And then I need zoom in, zoom out, zoom in, zoom out, because I need to find the change where my actual works are. What we suggest is opposite workflow. Then you just load that change like a small tiny object you are, and then you can isolate what was done, what's not done, like you are working in a small house. So the idea is that you always are focusing on the things relevant for you at that moment. And it's much easier to highlight the things. You cannot be lost in this huge project and so on. So these are some examples. You can, this presentation is shared, so these are QR codes. You can load, just go here and access to this templates, test how it works, and if you have any suggestions. This is an example of railway project, so it could be done on any type of the project. Or this project is particular I mentioned, so you can load just level 1 of the detail, and you will see everything shown now, but you won't see, I don't know, bed or chair, very complex, and so on. And the last but not least, I would like to explain another level of fit for purpose models. It's about data. So I talked about geometry and zones, but the last but not least are also our additional properties. So it would be excellent if we as a user can also decide which properties we would like to see and load dynamically at that time. So let's say Kobe, excellent example. Oh, you should just fill 100 properties for each element. I have, I don't know, 500,000 elements multiplied by 50, by 100, it's 50 million property values. And I just would like to see area, volume, maybe length, and maybe the type of, so let's say 5 or 10. So why load always? So there is a first disadvantage is I'm loading a lot of data. The second disadvantage is I'm lost in this data. There are a lot of asset managers who told us, you know, when we send a guy on the site to maintain something, they really don't want to see all your 100 properties. He just get lost. He would like to see only that floor and these properties. So you can slice the data based on to decide, okay, these are use case for asset management, these 15 properties are relevant. And you can have 2 levels, detailed and not. So in 95% of the cases, I will just use 10 properties, but then specifically I need to have 100, then I will usually not load until on entire project, but on contrary, let's say, I will just load all properties, but just for that level, because that makes sense to me at that moment. So this is, and now when I switch to the dashboards, so what are the pros and cons of the dashboard? So dashboards are very useful. First of all, you can use, let's say these are data checks. So you can use a Power BI or any other source. You can connect with other sources, your dashboard. So it's not necessarily coming from Excel or source. I can connect with the carbon footprint. They will show later one of the analysis. So these are the pros of this. The disadvantages that in this case, data solutions like Power BI are not dynamically decide which data you need. So the workflow in this case is when someone is publishing a clash dashboard, he defined the zones and just the dashboard for example, underground part of the building. So it has to be done upfront. So usually when you have 10 buildings on the project, user will create 10 dashboards for each of the buildings. And this is the way how the work is done. But good thing is that in Excel, you can slice automatically the data which will be presented. So the exported clashes will be just for that building. or just the clashes related to the certain task and zone, not everything. Because when you have a lot of things, it can slow down and have a lower performances. And these are some of the types of the dashboard. So you also here in a Power BI have just a certain data domain. So area analysis, this is just 3-4 domains: geometry, properties, elements, QTO, and zones. The others are not used. What we have in our CD is contrary. We try as much as possible to dynamically load the data just necessary at that time. So even if you have 4D, 5D simulation, we are just doing a cost analysis at the moment or clashes, the system will just load that data. So not everything. We try as much as possible to have this. So we call this fit for purpose BIM models, fit for purpose data models, fit for purpose organization of the model. So this is a clash report. So again, when you try to load on the cloud clash dashboard with all clashes with 500,000 elements, it will work slow, or in some laptops won't work at all. So instead of that, what is a use case when you will solve at the same time all clashes on the football stadium? Have you seen any meeting where you will start solving all these clashes? You're just discussing about one subzone at that time, and you would like that all for this week we are just talking about that, and then move forward. And the same goes with the cost estimate. You will never say, oh, now we will solve the cost estimate on entire football stadium, $1.2 billion at one meeting. Never. It's always zones or functional elements and so on. So these are quantity take-ups, which are just, this is a 5D estimation. So again, cost classification, everything could be fully customized, but this is, again, the zones, everything. But you see here, a lot of other domains are included: subcontractors, cost items, relationship between elements, QTO, budget, and so on. Selection sets. So this is a cost comparison. So this is an interesting, we have a lot of requirements from the clients for this type of report. So this is the true data coming from the B model, true only if the model is good, and the model they have in the contract, or the quantities they have in the contract. They really love to combine the cost estimate coming from accounting system like SAP and the cost or quantities coming from B model. And they know where the gaps are. And this is one of the very, very useful reports. I think next year, one colleague from L&T, their director, will talk from Larsen and Toubro about this dashboard. So, and then you have a schedule analysis, but again, a fit for purpose as much as possible you can have, or different types. So whenever you isolate the different groups, of course, different cash flows will be shown and so on. And just to mention this, and I will now finish with this part. This is an example of the workflow. Of course, I wanted to say it's not everything covered. We have a lot of things we are willing to improve, but this is an example how you can use this in the workflow of acceptance of executed works. So you always send the look-ahead plan. We never want that you manually select everything which is planned to be done on site. Then what is the purpose of the planning phase? You forget about this. The purpose sometimes is just to deliver Gantt chart to the client, and then forget about this and never update this. I hope this will be changed. But then you see a look-ahead plan, and this could be fully according to your needs. So if I have 5 subcontractors, I can send to 5 of them different look-ahead plans. I forgot to mention this slicing of the model can also be used for 2 additional very important things: access rights. So you can have a huge model, but then define, okay, you can see just structural works. Or there is even a use case for a clash detection where you can just load the properties of the models you control and not the rest. Sometimes on a highly sophisticated labs, factories, and so on, some of the producers said, according to NDA, our properties cannot be shared to anyone else. So you visually see the geometry of the element, but not a single property, because you don't need this for clash detection purposes. So these are the why this slicing of the model is okay. But then when you have, or in your company, you can have 3 field engineers, each see his own planned works, not everything, because he will be just confused. Then he sent what he actually did as the works, and then in some countries where you have a supervisors checks this. Of course, he can attach the photos or everything else. He can, of course, inspect the site and see what's happening, and has approved quantities. And now you have a full workflow where you can see what was planned, what was actually invoiced or submitted as a monthly report by the contractor, and what is approved. So you have a full, today how it's done, 50% is done. No, it's 40. Why it's 40? Because I said so. I'm just, of course, now exaggerating this, but you don't have a history, a track record, and so on. And what we found with this, although it's excellent for clients, it's also extremely useful for contractors. There is an example where on the second monthly progress report, by using this system, they identified that they have not invoiced the large chunk of the works. They simply forgot to include this in report. And this was shown here, and they were reminded to include this in report. So at the end, what we all want to have a win-win scenario and focus on a optimization of our works and to trust the system that they will really help us to have accurate data. Today, supervisors and contractors spend a lot of time just negotiating about the works which will be accepted or not. So this helps with this transparency that it's done in a more effective way. So these are now, let's say, dashboard monthly payment certificates per each subcontractor, different colors. Everything is transparent, and you can see all the information necessary. What I wanted to mention here, there are sometimes use examples when you will say, oh, but it's not entire railway. There are certain elements which are not modeled. Reinforcement is not there, or not all clashes are solved. I never saw clash-free model. I never saw LOD 400 model. I never saw in my life model which has everything which is enough for a 100% cost estimate. So you should never put this in requirements, and you will never have this. But if I have in this model 95% of my costs, risk allowance should be attached just to the 5% of the remaining part. So it's a huge, huge success. In the largest project, railway, in our region now, it's around 1.8 million. I would be very honest, because the model was developed 3-4 years ago, because it's a 6-7 years project. But around 70-80% of the costs are in the model. And still, it's extremely useful, and the client is very proud, and on the conferences show interesting dashboards and so on. So you should never fall in the trap, oh, but it's not there, or this small part is not modeled perfectly. You should always emphasize and highlight the fact, but the rest is there. Is this help or not? So just, I wanted to emphasize this. So even in this model where we got the award by buildingSMART a couple of years ago as the best technology project, even this project was not everything. And we said this, the idea is not to have everything, but as much as you can. You can see a visual, so cost performance index or earned value and so on, but I explained this number of times in presentations. Of course, this is, I believe you are aware of this. If you don't have a cost performance index, schedule performance index, earned value, there is no way you're going to manage the project. It's like I'm just seeing a photo and checking the quality of the concrete works without taking a cube. If you trust the guy who can just visually see and say, okay, this is good or bad, then you can also trust the project manager who, without earned value analysis, manage the project. And again, you can filter, decide what, and this is planned versus actual, and so on. And these are the advantage of Power BI, and this is that you can also have a lot of linear dashboards specifically designed for railways, tunnels, and so on. So this is again an advantage. I will skip this. Okay. Just how to do that. It's obvious, huh? Can I now move to another slide? Or now I'm just speeding up this?
Can you just click again?
Huh? Yeah, okay, this is one of the workflows, but you will have this presentation is available, right? Oh, it will be, so you can see this videos, how it works. So thank you for your time and attention. And then, do you have any questions? Yeah, please.
Thank you. Impressive what connection of data can look like. What you try to do is, I think, not only connecting data sources as files, but data sources as systems. So you can have the actual data out of that. How would it help for you if the IDS concept is accepted by the different software vendors? And how would it help that also the meaning of the data to be exchanged is the same? So then it is easy to make this connection, isn't it?
Yeah, for sure. And with, let's say, Thomas, Libby, Juan, anyone, we talked a lot about this with Leon, with now Arthur. So of course, this is tremendous help. So today, who had the chance to be at this IDS challenge, all this is huge help for all of us. So you can just load any of these IDS templates and sources and have a full automated process.
If your partners on the other side also accept it, because then it makes it easier. So it looks very complicated if you do that by hand.
Yeah.
But it may accelerate a lot if we use the same information base.
Yeah, but as I mentioned, it has to be fit for purpose IDS. So really optimal. So you should try to remove as much as information from your IDS as possible. This is the optimization way, not way around, oh, now I can add, I don't know, whatever I want. No, that's not smart thing to do. So try to eliminate, but then insist that this is delivered. So because another way around, what happened to us number of times, you have a beautiful model, but not a single quantity cannot be extracted. Walls, they are there, but 3 are missing. Windows are there, but 2 have not the proper dimensions. This is almost there, but not. Excavation almost there, but not accurate. Then usability of that model is 0. On contrary, you can say, okay, concrete works are perfect. That's much, much better. And we will just track the progress of concrete works on the first project.
Just to finalize our discussion, so as we started. So you mean with on purpose on use case? Can it be translated like that?
So this is discussion. I support Thomas' idea. That's what's missing today in IDS. Okay. Because today, if I have 3 use cases, I need to load 3 IDS files. I will strongly suggest, if I can, what Thomas presented today was, okay, I can just have a single file, but then just for the purpose of cost estimation, just check this part. So that would be, okay. And the phase of the project is also important. So not the same check for detailed design and conceptual design.
Okay. Hi. Hello. Very, very interesting presentation, as always, and very cool tools. I have two technical questions. First one is, do you guys actually split the IFC models, or do you like create some selection sets, and that's the, so if you split them, can you then share them around just those pieces? And also, how do you decide where to split? Is it like an arbitrary line, or do you go around the structural elements, or how do you do that?
Okay, excellent question. So they are literally split as a separated files, and this is a difference. So you have in our CD both sources, which are literally split, but then selection sets, which are just dynamically so. Sources are dealing with the entire data, loading of the data management of the entire system. So I load just that building. I can load the entire building, but then just with selection sets, see the one floor. But the rest of the data is also preloaded, let's say, and ready to be used dynamically. On the other side, if I want to have two buildings, the second building, I need to load the data from our cloud. The thing is, with how do you organize this? It's like in a selection set. You have a marker selection tool, or you can highlight anything, any part of the project, or filter for any property or any criterion. Bexel automatically, you can combine a different criteria. So it's not manual search sets, which I'm not a big fan of, because sometimes you need to have 3,000 search sets, so it's manual process, but system combines. So on each zone, so you have 3 zone levels, maybe 30 items, but then he can mix all this and create 1,000 small search sets automatically.
Cool. And second question is, do you have any recommendation for a tool that counts the number of triangles, as you said, the bigger complexity objects? Is there like an available tool where an architect can upload an IFC and check to see where the concentrated triangles are, so he can extract them?
You can use Bexel Manager or Bexel Engineer for this purpose, but there are definitely other tools. So we have open APIs. You can check edges, triangles. You can write your own algorithm. What is relevant? I can just give you an idea what we are using in our AI algorithms. So see the volumetric and area exposed of the elements, and try to correlate this with number of triangles. So if it's extremely large element, like let's say site, although it has a 50,000 triangles, you have to load it because you will not have a clue about the project without. But on contrary, if it's a small fitting, which has 5,000 elements, it's not optimal. So you can use Bexel for this purpose. Maybe there are other tools, but yeah, sure.
Thank you. Thank you very much.
Yeah. Thank you again.
Hi, I'm Juan Martinez. I am coming from the contractor side, so pure BIM practicalities. And my goal from today basically is just to let you know that all the things that Veljko has been presenting are possible, and are possible in with the tool that Veljko was presenting. Also, we are also oriented to the only the practical things, because we need to lean as much as possible the processes that we are applying, because of course when you are a construction company, you need to the time it's mine, of course. So basically, I'm going to be very quick in the presentation about who we are. Basically, we are in a PPP project, highway project mainly. Also, we have the main investor from it's Maguire, and we build an eco plan. And then we have the National Road Authority that is started by Vesen from Norway, and the main company that is Sotralink. Okay, then we are Sotralink Construction, that basically is a joint venture between WeBuild, an Italian construction company, FCC Construction, Spanish one, and SK Ecoplan, that is South Korean. Then we have also the duty to deliver a 7D model for maintenance purposes, because the client, that is Sotralink, want to perform the maintenance during the 15 years through the model directly. So basically, this is the first project build level 3 in Norway that is passing through all the different stages, from the, of course, the basic one, that the class detection, 3D information, and so on. It is also with 4D, 5D, 6D. That is, we have a high responsibility about the environmental social action here in to take care of. So basically sustainability, and also deliver to the final client the maintenance project. Yes. At the end, basically one of the main duties that we have in the project for the construction purposes is a suspension bridge. Suspension bridge of 900 meters long with an span, main span of 565 meters. So basically it's started last year, and it will be completed the 1st of June 2027. The project where we are, we are in the Bergen area. The project, it has around 14 kilometers. So we have 22 bridges and viaducts, 9.4 lanes of roads, 14 kilometers for bicycle roads, 19 underpasses, and 2.5 tunnels. So we have pretty much everything: tunnels, structure, suspension bridge, roads, landscape. So it's a very complex project, and what is adding a bit more in the complexity is like everything should be done meanwhile the traffic is running. So it has a lot of facing that we need to take care of course. Basically, some of the highlights within the Sotralink project is like we have more than 1,500 discipline model, all related to, of course, IFC standard, so open beam. We are managing through the different 11 areas that we are having in this project more than 3 million of objects, because here in Norway you need to build with the model. So the main source of truth is the model. So the 2D documentation is just a layer below the model. The model has prevalences of everything else. So everything should be linked to the model. So the model will remain as a unique source of truth for everything. So we have just a brief explanation about how we are managing this is through a concept that is called MMI status. So it's model maturity index. In each model maturity, basically what we are assuring in the approval process is a certain, let's say, parameter information that should be applied for the different department to be able to start working on. For example, related to QA department to start preparing the ITPs, also procurement department to start tendering with the right quantities to the potential subcontractor, to the market, and so on. Basically, we have not almost any 2D drawing, because also the entire chain from the designer side until the subcontractor, they are executing through the model. So basically, an excavation model, it's given to the machinery through the cloud, and they are uploading the feature lines, and the excavator, the operator of the excavator, has the 3D model inside of the excavator and exactly know what we want them to excavate. Then how we started with this for 4D and 5D, it's because it was mandatory to be able to govern this type of very complex project, because with all of these different discipline model plus all the information coming with them, it's impossible, just not to say almost impossible, I would say impossible to deal with people. So we need to establish some workflows, which is taking into consideration the different, let's say, inputs that all the departments are gathering for different sources. For example, quantity surveyor from the executed work that is one given by the subcontractor directly from site, cost control related with the air value analysis that they are doing, and the 5D estimation that we are going to have, the forecast, updating of the budget. Every 6 months, we are updating of the budget, also updating with the taxation and so on. And to be able to have this under control in a, let's say, manageable way, we should build up this let's say, connection among the different sources with, of course, a common parameter around, just to be able to gather all of this. Because this was a very complex issue at the beginning, where we were just thinking everything could be linked through the WBS code. But at the end, because we have different, let's say, deeper information depending of the discipline or the department that we are working on, we decided to invent the way of giving the right information in the right level. For example, for sometimes the cost department are going deeper than the planning department, because if it is the interest of the project to understand where we have spent this money or these resources. For the planning department, in the other side, they want to be more in detail related to the construction, let's say, task. So we have different level of understanding for the same object. So what we were implementing is something that is called key parameter. Also here in Norway, I don't know if you are familiar with, but we have a very strict method to just serve the information related with the bill of quantities, not the same that we have in the rest of Europe or in other places. Because we are not taking only, here in Norway, it's not taking only into consideration the quantities itself. It's also considering how you are executing these quantities. For example, if you see a rock wall, it's not the same. It has not the same price. Just blast the entire wall because you have enough cubic meter of rock just to go and blast. That only chip the wall. That is much more, let's say, expensive. So basically, we have all this information introduce it in the model with the concept that is called process code. Why we link also 4D and 5D? Because at the end, we are not using only 4D to just show a sequential planning, just to show how we're going to build, and afterward, when we are collecting the data and find the actual progress, to see where we are delayed. Basically, we would like to see also the money where it is running out. So also we can measure when we are mixing with the cost breakdown structure, the air value analysis that it is coming with the performance from the subcontractor. We are also developing inside tools that is giving the team the possibilities, not only the BIM team, also the engineering team and construction team, to understand the different maturities depending of the properties that should be inside. So basically, the topic is like, because I don't know nothing technically speaking, I need to give the tools to the engineering team to be able to validate the different MMI statuses, but they cannot go through the LOI matrix, level of information matrix, just to check each single property. So we have created an API that is called Property Set Evaluator. We will see afterwards, where the model it's linked with a SQL database, not an Excel, because for us an Excel is not a database. It's the proper server. You need to have a database where we are monitoring or pre-catching the information coming from this model before even that the single engineer is gathering the information. So in this way, we are, for example, validating models with reinforcement that it has 100,000 of objects. And you can ask me why you are modeling the reinforcement. This is a huge work, and it is because, as I was saying here, since the beginning until the end, the entire chain it's committed to deliver the items through the model that we are delivering. So the reinforcement supplier, they are used to manage this 3D model, so we are just giving them what we want exactly, because it has been how it has been verified, and then they are producing exactly, extracting the data needed and producing the bar bending schedule by their own. So we are not producing, adding, let's say, documentation just to, depending on what we want to communicate. Okay. We are also managing virtual reality on site, because at the end, one of the problems was that how we are going with the BIM to site, because my production guys was claiming a bit at the beginning, like, okay, the BIM is very nice, very pretty in the office, but I need to build. So at the end, what's going on there on site? So we just gather a virtual reality tool for them that this has accuracy of 2 centimeters on in infrastructure project is more than enough. So they are quite happy, even because we can save a lot of the interaction that we have with the survey department, not to have always the precise way of going there to and waiting them. So for this is the latest of the dashboard that we are gathering. This is this dashboard. It's updated every day, because every day at 8 we have 5 different designers that you can see there in the top right side, where they are serving continuously the model. So basically, we need to see instantly the level of health. So basically, how they are following the BIM execution plan that we have already setting up for them. So this is a brief view about the level of, let's say, completion that they have. Also, we have here much more detailed statistic about, you can see there the different LOI levels, that if they are in compliance or not. And also, moreover, what we have, if the comparison that we will see afterwards, okay, here, with the effective LOI matrix. If you see the third column starting from the left for the right side, sorry, it says effective LOI. So basically, what we are measuring there are 3 things. We are measuring the LOI, the MMI declaration that they are doing inside the parameter in the model. Okay, this is a manual input, basically, from the designer. Then we are measuring exactly the LOI performance that they are giving. So we can measure if what they are declaring and what we have as a real LOI, it's they are aligned or not. And there you can see that many or some of the model are over declaring. It could have a huge impact for the client afterwards, because basically what we are doing is also to declare our advancement, our progress in relation to the different design packages that here we call it control object. So it is critical and very important to share to our final client for payment and for the certificate that we are receiving from their side the right information at the right moment, without having the possibility after that to have a huge discussion, because at the end it seems that we were somehow cheating. Okay. This is the PSET evaluator that I was telling you before. Basically, what you can see here, it's that you can drag and drop a model directly downloaded from our CDE, or to choose in the second option, that this is what I did from the database. In this way, you can see a graph that we have created for the engineering people to understand in which maturity index they are. So real LOI, you can see there is 375, the designer MMI 375, which is not what is okay, but in the deliverable list, that is DL MMI, is the one that we are declaring to the client. So at the end, what we are going to declare. So this is a not compliance for our designer. So basically, we are coming back to them, just saying, okay, how you can declare that this was this development, but in reality, the parameter missing are those ones. So it's a very clear and straightforward and transparent way for all the parties to communicate without not having not end discussion about something that is theory. No, here it's data, and this is black or white. I mean, if you feel it, and if you feel it with a certain values, a certain type of values, we are giving this as a okay. Because of course we are not checking only the data, we are only making the quality assurance of the data, just understanding which values are the one needed for this specific parameter. In this way, we are also giving a step forward, just not validating data just for validating, basically. This is one of the Python script that we are developing here related to the PSET evaluator. And what I want to highlight here, it's like this was, let's say, a 100% right direction, I would say, because we noticed afterward, to be honest, it was by chance, but we noticed afterward that this was the right approach because we are directly linking, extracting the information with Python, with the algorithm, directly from the IFC file, from the text file that is coming from the IFC. Indeed, our designers, they were given through a secondary tool, they are checking. So this tool, when they are importing inside the IFC model, they are already treating the data. So basically, they were hiding or they were just showing that they were in compliance. What in reality it was not. But it was because how this specific software was treating the import of the IFC model. So I just this was a very good lesson learned that always go to the data source of this model. This was another developing that we had because here in Norway you need to transmit. This is an older project. Here in Norway they have a database, a national database that we need to report the incident. So that is called RUH incident. So basically it's unfortunate incident that the government is catching just to try to put some effort not to happen again. So basically what we're doing is letting the people to fill some data with a software directly on site. And then we are, with the API that we have created, we are exactly mapping the fields one-to-one to the information that we should deliver in LRAP. In this way, the people is delivering our tool, and then we are let's say, giving to the client exactly with one click the information. Because of course the NPRA, basically Standard Deviation, that is the National Public Road Authority, is not giving all the people the authorization to connect to their system. Basically, it cannot be one guy in the operator just sending. So we need to send control data to this environment. So it was good that we can do in a, let's say, in an organized way and without losing any time, because it is a recurrent process, weekly basis. Basically, now I will pass the word to Aleksandar. All the example that we are going to see here, it was done, of course, related to also Sotralink project. So I hope that you can see the practicalities on it. And of course, if you have any question afterwards or even now, just feel free to ask and just feel free to comment, because of course it was a very challenging project. It is a very challenging project. And overall, it is a high demanding of digitalization and innovation in construction site, and all related to practicalities. Nothing related to something that is not useful for the people who is on site directly.
Hello. Okay, hello everyone. I'm going to take over the next side of the presentation. My name is Aleksandar Ilić. I'm a senior BIM manager and the product owner in Bexel company. And I will try to give you our perspective of implementing digital BIM workflows on the project in coordination with the team from the contractor. So, I mean, I'm going to skip this basic information about the company because Veljko covered this. I will just point out that no matter how many clients you have, how many new projects you engage, there's always something new that you learn from how people approach BIM and implementation on BIM, and what are specific challenges of certain country, of certain market, and of certain legal framework, I would say. So we'll start as always from the challenges, of course, and as with everything else, challenges on this project were slightly different than what at least me personally I have encountered before. So yes, we figure out that people are still thinking in their own discipline silos. But in this case, we cannot say that they didn't have the communication in a proper way, because they had pretty well established a data set and data structure. So they were producing data in the proper way. The data was integrated in the IFC model. What was lacking is from all of these participants to have a wider picture how the data they produce is going to be used by other stakeholders, because you cannot just keep producing the data in the way you're used to do and give away your deliverables without having idea how those information are going to be used in the following phase by the following participants on the project. So the first step was, of course, to integrate all of this together, to create a federated BIM model, and to start, of course, first analyzing the quality of this data. And I mean, we just covered how many different analyses. Juan just covered how many different analyses were performed, and how much they actually put an effort to make sure that the data is structured in a proper way. And of course, after that, then we started integrating all of this data and specifying the workflows, because yes, we have data, but we need the workflows. How we're going to integrate all of these different disciplines, how we're going to actually start using this data, how make it to use on the construction site, and how we're going to utilize all of this that is produced within the model. So we were basically establishing single source of truth, where we wanted to just make sure that all of this is working as one consistent single source of truth that is reliable for every stakeholder. So it was important that we had fit for purpose data. That means that we were able, from all that huge pool of data or the lake of data, that we can just easily identify this piece, this part of data that is relevant for certain stakeholder, and to deliver it on time. Because it doesn't matter if you have 800 different properties in your model, if those properties, if this data cannot be used properly, if you cannot easily navigate to the specific information in the specific a window of opportunity, a window of time when you need it for a certain user, it doesn't make much use. So what was very important in this specific case is that we have machine readable data. We had a lot of data from different disciplines that were just, the human understands that he wanted to say this, and we, when you open the model, when you see that property, you understand what he was meaning with that property, but the machine is not. So one of the probably major concerns at the beginning was just to explain people that you need to name the properties in a certain way so that software could read it. Okay, we would understand that you were meaning that a cost code is a cost code, but the software just understands it if it's properly formatted in the way to be read. And of course, the main goal was to use this extensive base of information and to just with the team integrate all of this and to assemble the workflows that will utilize all of this information inside the model. And of course, we're just going through these workflows, and today I will try to I just picked few interesting examples, I would say, where we more or less innovated a bit, and where we have specific challenges that basically inspired us to develop something that we didn't even think about before this project. So as I said, we get the model data layer with the data from all of different disciplines, from the location data, 4D, 5D, even CO2 emission equivalents, all of this was inside. It was structured pretty well. So the people after a short time were pretty disciplined in delivering the data properly. Just the main challenge after that was, let's just put those data in use. And for this, we of course use this complete ecosystem of our softwares as well as other softwares integrated through API. And one of the first challenges that come to our mind is just the federating the model and updating the model itself. We started with over 1,000 IFC files. It's now over 1,500 because the model is progressing and is developing, and it is updated regularly. And the team told us, okay, we're just losing too much time in a simple update of the model, so we cannot even start, checking the quality and using other workflows, just because of how large the complete data set is. So the first step was, okay, let's automate this process. We don't have to initialize user interface and the complete software interface every time we update the software. That's pretty automated function. We can practically move the people out of this process. We just specify this Bexel automation software that just practically gets the downloaded IFC files from the server, and so over 1,500 IFC files, and updates it into 11 different federated BIM models for 11 different construction areas, basically. And of course, in the future, we are planning to optimize and automate also the other process. Let's say not just automate the update of the model, but let's also run the clash analysis in the background and just deliver the report. So or run the data analysis, data check, and just deliver the report. So I don't know, you can go on Friday night home, just leave the software to update all the data and maybe deliver the reports on the Monday afternoon, so you can start working on your work and not wasting your working hours, engineering hours on a time-consuming task like updating the models or just exporting the reports. So yeah, it was updated, as I said, more than 1,000 different models at the beginning. Now it piled up to 1,500, and it was regularly updated through this automated function. Then the next interesting workflow from my side, as someone who was just assisting in implementation and setting up the workflows, is that even though we have this really rich data set of more than 800 parameters, we still miss some important data. So when you put everything together, when you start connecting the elements, when you start connecting the pieces, 4D, 5D, and so on, you just realize that someone who just didn't think that certain parameter is important for his discipline, and it's his, I would say, he had to actually deliver that information. It's in his scope of work. They didn't think it's important from their point of view, but it is very important from the point of view of the other discipline. And then we had to deliver this data somehow and to integrate it after the designer finished their work. So what we had to do, again, we have to rely on existing data. So, okay, if somebody has in his own silo, let's say, some information that was not integrated in the model, but he can give us, relational property that says, okay, if you go to the elements with this value of the property, you can assign this value of this other property that you need to that specific element. So that was the way to actually additionally enrich the models with some data that was missing. We were also using clash detection, of course, which is, it was used in a classical way for defining the clashes and the problems on site. But what was innovative approach and what was interesting, at least for me, something new, is that say that we had the situation where we need to add these missing properties, but we don't have any existing property in the model to relate to. So let's say some locational properties that were simply missing, and to go back and to just add this property in the authoring tool was just way too time consuming. So what we actually exercised is use a containment clash detection. That means that we just identify, let's say, that certain elements are contained within certain bigger elements or spatial elements, let's say excavation of the tunnel, and then we could automatically through API enrich the elements that are inside this area with the, let's say, location parameter of that area. So we were able to basically define the relationship between two elements and to automatically transfer information from one element that was properly enriched to many different smaller elements that were simply missed or just were misjudged in the design phase as irrelevant for enriching it with these location parameters. When it comes to the 5D, and in this case, we were just going with the import of the existing cost database because the whole 5D team has very, very rich database for the cost. They also have a set of parameters that was set up at the beginning of the project to be used as a sort of a vehicle to connect the elements with the cost items. So here, I would say the biggest issue was, again, to understand, to explain people how important it is to keep their data in a machine readable format. Because yes, when somebody explains me, over the Teams call, that these three parameters combined are defining the link between a certain cost item and certain element, I understand it. But if I try to utilize that data in the software and to automate the process, we have to speak the same language. Then we have to rely upon this agreed set of naming conventions, agreed set of parameters that we have to follow. So after a few coordinations, we just figure out this workflow. And the important is they did have this much harder part, and that is to have all of this data. We just need to little bit smooth out the way it is stored and the way it is delivered to the other stakeholders in the project. This is just a small example of a dashboard, a 5D dashboard that we succeeded in developing in this project. So and with this dashboard, we actually explain people why it is important that we integrate all the information from your domain with different domains through federated BIM model, because now you can see that you can use different property sets, so from different disciplines, and you can practically slice or break down the existing, let's say, 5D parameters here. So you can slice the budget according to completely different set of parameters. So location-wise, you as someone who is just in charge of 5D, you probably don't think too much about the location distribution of the cost. It is important that you have good numbers. It is important that at the end, the cost of the project is controlled. But when the project progresses, when someone is a contractor, when somebody is on site, it is very important for him to know what is happening next week. It is very important for him to know what is happening on the 550th meter of the tunnel. What are the materials that have to be prepared? What are the works that have to be executed, and so on. So when you just look at the broad picture, you need to understand why it is important to integrate all together, and not just to keep the information for itself. Because a lot of professionals, they have this this approach. They say, okay, if you need this information, I can always deliver it to you. But that's not the point. The point is that I can use my set of information, and that I can break down and I can slice your data in the way that is useful for my phase of the project and from my role on the project. So not only to get the information from you, because I believe that you did your job well, but it is important that we are integrated so that we can all see the data in the way that is relevant for us and in the time where it is relevant for us. So I mean, some of the examples here is just to see it by the excavation phases, let's say. So, if you are on the construction site, if you're thinking about 5D, this is the important thing. The information about how much the whole project cost is not way too much relevant for you. You need to solve the problems that are coming in the next few weeks, in the next 50 meters of excavation. You need to know what are the resources needed. You need to know what are the materials needed for all of this. And you want to see all of this. You want to see the animation of the cost. You want to see when the certain cost, when the certain expensive works are going to start, and so on. So this is something that you need to think about when you are in your discipline silo, I would say, and preparing the model. So the next workflow, let me just see if it's gonna, yeah. So the next one was a 4D, 5D construction planning. So generally integrating the 4D. And here the approach was that we didn't use from scratch, creating the intelligent scheduling using our advanced algorithm, or we were relying upon pretty well-structured planning workflow that the team already had. So they had the Primavera schedules. They specified the properties in these Primavera schedules for every task. What are the properties from this agreed property set that are relating certain groups of elements with the certain tasks? So again, as with the cost, we just basically translated this set of properties into machine-readable rules, and we connected the data, the elements and the schedule. And the first benefit that came out of it is that when you create the simulation, the 4D simulation, the planners could see how well established their schedule is, because they see if something is illogical, they see if, excavation is jumping, from the first meter of the tunnel to the middle of the tunnel and so on. So they could actually visualize their data in a proper way. And of course, after that, we were also able to use a hybrid model, basically, where we use their schedule, we connected through the property sets, and then we just additionally expand the detail of their schedule by adding another level of complexity. Let's say when they just specify that this one task is dedicated for a group of 4 different consequent works, where we were able to just automatically, using our advanced planning engine, just add these activities and just make this more detailed for their schedule. And this is just one of the examples how the end result looks like. So basically, you have integrated schedule, you have expanded the schedule, make it more detailed for the project using other parameters, location parameters or cost parameters in this case. And this is also important part where we were able to just subdivide the models when they're updated on the CD, what Veljko mentioned, in a way that is much more practical from somebody who's project manager than the designers. Designers probably have 100, 150 different source files for this specific model, and they're dedicated by discipline or things like that. For us as a project managers, it is important to divide model probably by the left tube, west tube, east tube, to know what is the excavation, what is the discipline, and so on. And we were able to completely reorganize the federated BIM model in the CD environment and to allow other participants to actually load only the part of the data that is important for them. So only the part of the tunnel that is related to their work, only the discipline that is related to their work, and not to load complete model or to try to fit with the logic of the designers and try to load all these different IFC files with a naming convention that is not really intuitive to them, and to just be in the environment that is not very clear for them. So again, combining the information from 4D and from the location parameters and from the discipline parameters, we were able to integrate this and to make this the same information available for different stakeholders in different phases of the project, and to make it more practical than it was envisioned at the beginning. So I'm going to just skip for the next slide. So besides all of this, I would just point out one more important workflow, and that is reporting and analytics. Okay, you're going to have federated BIM model. You're going to have this big lake of data, well organized, well structured, well connected. But again, if you're someone in the chain of command in the stakeholders of this project, you need the specific data and the specific time. And you don't have time and you don't have knowledge of the project to just dive into this lake of data and to find the specific thing that you need. So we had to figure out with the team what is the proper way to deliver this data to different stakeholders and the proper time, because every workflow in your project life cycle has its own place and time, but every workflow is followed by the reporting and analytics, because without that, you cannot just make decisions on the project. So we had to just use this data in a smart way, to break it down in a smart way, and to deliver it in a smart way, so that people can understand what they are seeing and that people can relate to what they're seeing. So we were basically assembling these customized reports that are highlighting the important pieces of this puzzle to different stakeholders, and that are presented in a such way to be readable for these people. So it is not the same thing if you're looking at in a flat table with certain data, or if you're looking with a well-organized chart, or if you're looking in the color-coded model that actually shows you exactly certain data, how it is spread out on the model side. And here, just for example, I would just point out something that was very interesting and new to me, is the CO2 emission equivalence data that was already in the model. And we just had idea, let's try to utilize this data and to try to show it in a proper way, to allow people tomorrow on the project to properly track the carbon footprint of their project. So one of the first things we were able to, as you can see, completely reorganize the model structure. So the model structure was set up by the sources. Now we are reorganizing it by objects and by the discipline of the road, which is much more practical from the standpoint of CO2 equivalent analysis. So then we were able to export different custom breakdowns. That means the coloring schemes that are coloring the model in a different ways, displaying the data in a graphical way. Then we were able on the CD to simply allow access to all the different participants to this specific model with this specific data. They could load the data set that is important for them only. So they could focus, okay, if this is area 11, I'm just next 2 months have to execute this specific part, K802 or K803. I just have to load that set of data. I don't have to load the complete model in order to see some piece of data that is important to me. First, maybe I don't have the computing power, maybe I don't have time. I just want to be more efficient. And this approach allows us actually to do it in a more efficient way. So people are able to access, people are able to load the information that is relevant for them. People are able to visualize the data. So not only to see the data as numerical information, you can color code elements by specific property sets that are actually present in the model. So you can basically specify certain color for certain area in this case, or for some completely different parameter that is relevant for you. And you can easily navigate and you can just go through the model and you can visualize how this specific parameters is set up in the model. Let's say the work packages, work package number. So you can now see that the same work package is present in a different areas of the model, or you could see different spatial areas. Then we were able to export to develop this interesting dashboard that is actually showing what is the carbon footprint of different materials. And on this graph, you can see that the height of the graph is showing how many carbon is actually emission for 1 kilogram of this material, and the bubble size is showing you how much material is actually used on the project. So the main goal was to just limit the use of the carbon intensive materials and to use the materials that are low carbon intensive on a larger scale. So you can just simply go through the model and you can trace the information. So the traceability is a very important feature of this approach, so that you can trace exactly for every element the information, how it was calculated, and you can make sure that the data is relevant. So you can color code, let's say, by the CO2 intensivity of the different materials. You can see that certain steel types are in red, so they have very high quantity of CO2 emission per unit. And you can see how limited the use of such steel is. So only for the areas where it is, you have some specific structural needs for that. And then you can see that the materials that are used extensively are mostly somewhere in the middle. So those are concrete materials that are not as polluting as the steel. And I mean, this gives you the whole perspective. The next step is just to use the same data and to combine it with the schedule, with the time dimension, so to see how our CO2 emission equivalents are going to be spread out during the project execution. And then we're going to also track planned and actual. So we're going to compare this spread of the CO2 emissions as it was planned and the real data that will be delivered by the contractors during the project execution. So yeah, that would be it from us today. Thank you for your time. And we're open for questions.
Any questions?
Thank you very much, Ilić. And then my question is that this system I know very well, and then I feel it's quite sophisticated and integrated. But the one thing that we, the construction company, face is how to manage progress in the construction. So this virtually the changing the status color, that's very easy. But how to pick up the reality and then reflect it to the model is a very big problem. And then as you or the guys here know, the many person touching the camera 360 degree walks through and then the overlay the BIM model. And then but it's almost all those the thing are the hand, not automated. So do you have any good idea, some drone or robotics to take a picture or that kind of automatically thing, robotics, and then your system? How do you connect, or do you have any good idea?
Okay, we already actually had some implementations of reading the data out of the sensors and implementing it. So the system is open for that. The question is only if the technology of catching the progress is already mature. It's probably an experimental phase for now. What I can tell you, what is my personal experience from the construction site was like 4 years ago, 5 years ago, we were already using these drones. They're much more prolific now. Let's say for construction works, we were just flying out the drones, taking pictures, taking videos, and then selecting the elements based on this. It was pretty easy for us to relate this. Of course, the next step is probably to automate this. We already have the drones and the systems that are mapping out the surfaces, or the laser scanning that could generate this. So of course we need advanced algorithm that will just read this data and then automatically select those elements. That is the future. We haven't used it yet in practice, but yeah, I think that is the future. For now, we're trying to, with these collaboration tools, to ease people this process, because people were doing this even before. You just use this piece of paper or Excel spreadsheet and you go and calculate what you see on the construction site. We are now trying to make this less difficult. So we have ability to give you the look ahead plan, so you can see what should be executed next week. So you can then your search for selecting the elements is then pretty narrowed. So okay, this is what I really succeeded, this is what I failed, and I can return that information using BCF file. So I can use with different platforms, and I can easily understand this because it's visual. That is our approach for now. We're trying to first to give you a look ahead plan, to give you a way to work on a tablet, to work on a mobile device, so that you can open actually Excel CD or any other cloud-based platform, to open it on site and to just directly select the elements, and then our system reads the information from the elements itself. You don't have to calculate in some Excel if this column is 5 cubic meters or not. You just have to say that this column is in this status of execution, basically. But yeah, the future is definitely to have a technology that automatically captures this, and that we have.
Yeah, thank you. So time is limited, so thank you very much.
No, sorry. I would like to, just because I'm coming from the site just directly, that in my opinion, this tax should be given by a subcontractor. At least here in Norway, they are very familiar with digital tools. So at the end, to give them the possibility to check in a model the status and give it like a done, and then quantity surveyor from office need to go there and just double check that it has been done, you have something, because they are the first one that are interested to get the money. So we have the easy way of doing. If you want to measure, let's say, progress in the real time. Also related with the first question that you were giving, we have also in our project, because it is ongoing. So basically, you need to build meanwhile the traffic is running. So we have a lot of SCADA system where you need to continue monitoring certain structures, certain settlements, to understand if the work that you are performing beside an entrance of the tunnel, it's basically aligned or not, or basically it should be taken care of. Stop the work because basically the settlement went down 2 centimeters when the maximum could be only 1. I don't know. So at the end, it is possible to take all this data from the cloud, because this is live every hour, every 5 minutes. You can set up the time where you want this, let's say, SCADA system to monitorize this point. And then I think that it's pretty easy to integrate, for example, with the GIS system that we are also connecting to, because the client want to see, want to visualize. But the important thing here is to, in my opinion, to just not give false, let's say, alarms to the public. The data needs to be controlled. So someone should be verifying this in the middle from our side as well. Because if suddenly a bird is passing too close for the SCADA system, it will be like something has happened. So you are going to make a fire where there is no fire, basically. So it's good that someone from the construction side, some responsible guy, we have a monitoring guy, just approving or giving the acceptance that this data was right.
Yeah, thank you for your opinion. Yeah.
Yeah.
Very impressive that you control the quality of the data, because this is the heart of all. If you don't have reliable data, you can't do all that stuff. To control the needed or defined attributes, I think it's quite easy. So how you do that with the geometry? So how you control that the geometry fulfills the needed granularity or exceeds it?
Yeah, basically what we have in the BIM execution plan, and it was part of the first Power BI dashboard of the health of the model, we were gathering the file size. So we were having a chart about related to the discipline, which is the file size that it suddenly were delivered by the designer, where they are breaking, let's say, the rules. So we are in this, we can have the alarm, just we need to go and verify, and then let's check if, of course, it should be splitted, because it's, I don't know, a pylon of the suspension bridge. Of course, for the reinforcement, you should split it. So let's see the right approach to split the reinforcement of this pylon. Or if it is a matter of road, because they are exporting in thousands of triangle, of course, this will be rejected in the MMI evaluation.
Okay, thanks.
Okay. Thank you.